Okay, so my goal for this project was to get my 3D printer to basically print polar functions. I said in here that I wanted to convert between polar and Cartesian equations, but I only ended up converting from polar to Cartesian, not Cartesian to polar. And my learning goals were to challenge myself at converting between polar and Cartesian coordinates. Again, I only converted from polar to Cartesian, not between the two. And also to learn a little bit about Python on the way. And what actually happened was I didn't end up doing anything with G-code. I wanted to maybe be able to add the ability for the user to enter in their own equations, but I didn't do that either. But I did convert a few equations that were somewhat difficult. Also, looking at the equations themselves, like this, looking at the end result really sometimes helps to figure out where to go if I'm stuck, which I did definitely get stuck. What I did was take the equations that I already converted, stuck them in Python, and plotted them, and let the user choose which equation they wanted to plot, basically. Or just pick a number between 1 and 4, and it would plot one of the equations that I put in there. So let's get started. So now I'm just going to discuss how I got one of the equations, because I did 4, and I don't feel like discussing 4 equations. So, to get started, we need to know a few things. We need to know that x is equal to r times the cosine of theta, y is equal to r times the sine of theta, and r squared equals x squared plus y squared. And then you would also need to know all of the trigonometric identities so that you can use those to help with conversion as well. So the one I'm going to go over, it's r equals b squared over a times cosine squared theta. So what I did was I realized that r, right here, r is equal to x divided by cosine. And then I multiplied both sides by cosine, and that got rid of this cosine and got rid of that little squared right there because they canceled. And that leaves me with this right here. Then I multiplied by the a cosine theta, and then I rewrote cosine theta as x over r, because cosine theta is x over r. And so when I did that, it's just x times a times x over r, so x squared times a over r. And then I multiplied by the r, and so I got stuck. And so what I did is I looked at the equation and I noticed that this b squared was b to the 4th, and so I just squared both sides, and then this became b to the 4th, and this became r squared. And because of this identity right here, r squared can be rewritten as x squared plus y squared. And then after I did that, there are no more polar components in it, and it's good to go. So now let's just go over briefly the code. Pretty simple. All it does is the program asks the user which equation they would like to graph, 1, 2, 3, or 4. The user doesn't know which one it is, but, surprise. And then the computer asks for an a factor and a b factor. That should be an a stretch factor. I don't know if that really makes that much, if that's the correct notation, but whatever. And since equation 4, which is the one I showed, has a b in it, I noted that if equation 4 is called, it would ask for an additional stretch factor. And then I asked for the number of points, which is exactly what it sounds like, number of points to plot. And then these are all of the Cartesian versions of the polar equations that I converted. And then down here, all it does is it says it's plotting the particular equation, and then it just plots it right here. And then this, if you enter an option that's not 1, 2, 3, or 4, it'll yell at you. So let's go ahead and try it. if I enter equation 1, which is this equation right here, it's going to ask for A. I'll just give it value of 1, and 1,000 points looks nice, so that's what I'll do, and give it a... Okay, I think I fixed it. Let's try it again. Okay, equation 1, stretch factor of 1, and 1,000 points. Don't do it again. There we go. And that's what it looks like. Cool, there's equation 1. Do it again for equation 2. Stretch factor of 1, 1,000 points. There's equation 2. Again for equation 3. There we have it. And last but not least, equation 4. This one's going to ask for 2 variables because it has 2 variables, so we'll do just 1 for both. And then put in 1,000 points. And there you go. Cool. And then if you enter 5. What? Okay, I think I fixed it. So now if you enter something that isn't 1, 2, 3, or 4, it would just say you didn't enter a valid option and then just exit the program. So let's try it. Enter 5. There you go. Cool. And that's the end of my SDL Project 3.